According to the National Electrical Code, specifically Table 310.15b16/4/0, American wire gauge welding cable with THHN insulation rated at 90 degrees Celsius has an ampacity of 405 amp. This ampacity applies under specific conditions. Firstly, the cable must be used as a single conductor. Secondly, it should not be installed in raceway or cable tray. Thirdly, the cable should be laid directly on the floor or ground. These conditions are critical for ensuring the cable's ability to dissipate heat effectively and maintain safe operating temperatures. If the cable were installed in a raceway or cable tray, the grouping of conductors would reduce its ampacity due to increased heat buildup. The National Electrical Code tables provide ampacity ratings for various wire sizes, insulation types, and installation methods. These tables are essential for electrical engineers and electricians to ensure electrical systems are safe and compliant with regulations. When selecting a cable for a specific application, it's important to consider several factors. One of the factors is the load requirements, which determine the minimum ampacity needed. Another factor is the ambient temperature, which can affect the cable's ability to dissipate heat. The installation method also plays a significant role, as it impacts the cable's ability to stay cool. For example, a cable installed in free air will have a higher ampacity than one installed in a conduit. The type of insulation is also crucial, as different insulation materials have different temperature ratings. THHN insulation is a common type of insulation used for welding cables due to its high temperature rating and resistance to moisture and chemicals. It is important to consult the National Electrical Code to determine the correct ampacity for a given cable size, installation type, and installation method. The National Electrical Code is updated regularly to reflect changes in technology and best practices. Ignoring the National Electrical Code guidelines can lead to overheating, insulation breakdown, and potential fire hazards. Therefore, it's crucial to adhere to the National Electrical Code requirements to ensure electrical safety. When using welding cable for temporary emergency power installations, it is crucial to consider the specific requirements of the application. Welding cable is typically designed for high current, low voltage applications such as welding. However, it can also be used for other applications such as temporary power distribution. When using welding cable for temporary power, it's important to ensure that the cable is properly sized for the load and that it is protected from physical damage. Additionally, it's important to use appropriate connectors and terminations to ensure a safe and reliable connection. Furthermore, it is essential to regularly inspect the cable for any signs of wear or damage and replace it as needed. Always follow the manufacturer's instructions and the National Electrical Code guidelines when working with welding cable and electrical systems. Using the incorrect cable size or installation method can lead to serious safety hazards. The National Electrical Code provides detailed information on the safe installation and use of electrical equipment. It is essential to consult the National Electrical Code before beginning any electrical work. The National Electrical Code is a comprehensive set of standards that covers all aspects of electrical installations. It is important for electricians and electrical engineers to stay up to date with the latest version of the National Electrical Code to ensure that their work is safe and compliant. The National Electrical Code is published by the National Fire Protection Association and is updated every 3 years. The National Electrical Code is widely adopted in the United States and is also used as a model code in other countries. The National Electrical Code covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. The National Electrical Code also includes specific requirements for different types of occupancies such as residential, commercial, and industrial buildings. The National Electrical Code is an essential resource for anyone involved in the design, installation, or maintenance of electrical systems. It is important to understand the National Electrical Code requirements and to follow them carefully to ensure electrical safety. The information provided in the National Electrical Code is based on years of research and experience and is designed to protect people and property from electrical hazards. When working with electricity, it is always important to exercise caution and to follow safe work practices. Electricity can be dangerous, and it is essential to take all necessary precautions to prevent accidents. Always to energize electrical circuits before working on them and use appropriate personal protective equipment such as gloves and safety glasses. If you are not qualified to work on electrical systems, it is important to hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it is essential to have the necessary training and experience to do the work safely. The National Electrical Code is a valuable resource for ensuring electrical safety, but it is not a substitute for proper training and experience. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns about electrical work. Welding cables often employ a fine stranding of copper conductors to enhance flexibility. This flexibility is crucial for applications where the cable is frequently bent or moved, such as in welding operations or temporary power setups. The fine stranding allows the cable to withstand repeated flexing without fatiguing or breaking. The overall diameter of the 4/0 American wire gauge welding cable can vary slightly depending on the specific manufacturer and the type of insulation used. However, it is generally around 0.6 to 0.7 inches in diameter. This relatively large diameter is necessary to accommodate the large cross-sectional area of the copper conductors required to carry 405 amps. The weight of the 4/0 American wire gauge welding cable is also significant, typically ranging from 1 to 1.5 pounds per foot. This weight is due to the large amount of copper used in the cable and the heavy-duty insulation. When installing the cable, it is important to consider its weight and to provide adequate support to prevent strain on the connections. The voltage drop in a 4/0 American wire gauge welding cable can be calculated using Ohm's law and the cable's resistance per unit length. The voltage drop is the reduction in voltage that occurs along the length of the cable due to the cable's resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Therefore, it is important to select a cable size that minimizes voltage drop. The resistance of the 4/0 American wire gauge welding cable is typically around 0.5 ohms per 1,000 feet. This resistance can vary depending on the temperature of the cable and the specific type of copper used. The ambient temperature affects the cable's ampacity because it influences the rate at which the cable can dissipate heat. At higher ambient temperatures, the cable's ampacity is reduced because it cannot dissipate heat as effectively. The National Electrical Code provides correction factors for adjusting the cable's ampacity based on the ambient temperature. These correction factors are essential for ensuring that the cable is not overloaded at high ambient temperatures. The dirting factors specified in the National Electrical Code are used to reduce the ampacity of a cable when multiple conductors are bundled together or installed in a conduit. These dirting factors account for the increased heat buildup that occurs when conductors are grouped together. The National Electrical Code provides specific dirting factors for different numbers of conductors and different installation methods. It is important to apply these dirting factors correctly to ensure that the cable is not overloaded. The grounding requirements for temporary power installations are specified in the National Electrical Code. Grounding is essential for protecting people from electric shock and for preventing equipment damage. The National Electrical Code requires that temporary power installations be grounded in accordance with the applicable requirements for permanent installations. This typically involves grounding the generator frame and connecting the grounding conductor to a grounding electrode. The overcurrent protection requirements for temporary power installations are also specified in the National Electrical Code. Overcurrent protection devices, such as fuses and circuit breakers, are used to protect electrical circuits from overloads and short circuits. The National Electrical Code requires that temporary power installations be protected by overcurrent protection devices that are properly sized for the load. The National Electrical Code also specifies the types of overcurrent protection devices that are permitted for use in temporary power installations. The labeling requirements for temporary power installations are specified in the National Electrical Code. Labeling is essential for identifying electrical equipment and for providing important information about the installation. The National Electrical Code requires that temporary power installations be labeled with information such as the voltage, amperage, and date of installation. The National Electrical Code also specifies the size and location of the labels. The inspection requirements for temporary power installations are specified in the National Electrical Code. Inspections are essential for ensuring that electrical installations are safe and compliant with the National Electrical Code. The National Electrical Code requires that temporary power installations be inspected by a qualified electrical inspector before being put into service. The inspector will verify that the installation meets all of the applicable requirements of the National Electrical Code. The maintenance requirements for temporary power installations are specified in the National Electrical Code. Maintenance is essential for ensuring that electrical installations continue to operate safely and reliably. The National Electrical Code requires that temporary power installations be maintained in good working order. This includes regularly inspecting the equipment, tightening connections, and replacing worn or damaged parts. The removal requirements for temporary power installations are specified in the National Electrical Code. The National Electrical Code requires that temporary power installations be removed promptly when they are no longer needed. This is to prevent the accumulation of unused electrical equipment, which can create a safety hazard. The National Electrical Code also specifies the procedures for removing temporary power installations safely. When using a portable generator for emergency power, it is crucial to follow all safety precautions. Portable generators can produce dangerous levels of carbon monoxide, so it is important to operate them in a well-ventilated area. Never operate a portable generator indoors or in an enclosed space. It is also important to protect the generator from the elements and to keep it away from flammable materials. Before starting the generator, make sure that all electrical loads are disconnected. This will prevent the generator from being overloaded. Always use a ground fault circuit interrupter when connecting electrical equipment to the generator. This will protect you from electric shock. Never refuel the generator while it is running or hot. Allow the generator to cool down completely before refueling. Store fuel in a safe location away from heat and ignition sources. Always follow the manufacturer's instructions when operating and maintaining the generator. If you have any questions or concerns about using a portable generator, consult with a qualified electrician. The National Electrical Code provides detailed information on the safe installation and use of portable generators. It is essential to consult the National Electrical Code before using a portable generator for emergency power. Always prioritize safety when working with electricity and follow all applicable codes and regulations. The information provided in this narration is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before beginning any electrical work. Failure to follow safe electrical practices can result in serious injury or death. Therefore, it is essential to take all necessary precautions and to follow all applicable codes and regulations. Remember to always prioritize safety and to consult with a qualified electrician if you have any questions or concerns. Electricity can be dangerous, but by following safe practices and adhering to the National Electrical Code, you can minimize the risk of accidents. When working with electrical systems, it is essential to have the necessary training and experience to do the work safely. If you are not qualified to work on electrical systems, it is important to hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it is essential to have the necessary training and experience to do the work safely. The National Electrical Code is a valuable resource for ensuring electrical safety, but it is not a substitute for proper training and experience. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns about electrical work. In summary, confirming the 405 amp rating for 4/0 American wire gauge welding cable with THHN insulation at 90 degrees Celsius is correct under the specified condition. Namely, that it is a single conductor, not in a raceway or cable tray, and laid on the floor or ground. Always consult the latest version of the National Electrical Code and a qualified electrician for specific applications and safety guidelines.